Good morning, Nashville. How is everybody? Great. I am truly honored to be speaking at the very first Serverless Days Nashville. It's really great to be here. A bit chilly this morning, kind of a cold start in Nashville. It's my only serverless joke, so okay. All right, so today I'd like to talk to you about the reasons why enterprises are loving serverless. So my name is James Beswick. I'm a developer advocate for AWS Serverless. I've been a serverless geek for quite a long time, about nearly 3 years now, and I've built a lot of different solutions all the way front to back using serverless tools. Before I was at AWS, I was a product manager for quite a few years, and then before that, a software developer for a long time. So I've really enjoyed being in the sweet spot of technology where we can use technology to solve customer problems very easily. And prior to this, I worked in quite a few different startups where I used serverless tools, and I worked for larger companies like Rackspace and USA and Morgan Stanley. And when I'm not solving the world's problems with serverless, I like coffee, theme parks, and travel. So it wasn't long ago that Lambda was launched, and serverless was an absolutely brand new concept. And when you think about how many customers are using AWS Lambda today, it's truly astonishing. One of the main reasons for the success is the simplicity of deploying highly available, scalable applications. So I was thinking about Hello World. My first Hello World I did when I was 5 years old on the Commodore 16, which is quite a long time ago now. And it's a great rite of passage we all have when you pick up a new programming language or a framework. And it's easy for a developer. You can basically pull up your terminal, run the one line of code, and feel that you've built something. But it's actually a lot harder for enterprises. If you think about Hello World for an enterprise, it starts to look a bit more like this. So in a dev test environment, you have a server. Then you have an operating system on that server, Windows, Linux, whatever you prefer. And then you've got to pick a runtime, PHP, Python, Node, your choice. Then a web server, and then some code. And in this example, I've got Node.js Express. I've got some boilerplate here. I'm setting it up, and you can see it's listening on a port, and it's handling this route. And all of this is here so I can run this one line of code. And all of this needs maintaining, patching, feeding, and watering just for that one line of business logic. The rest is all overhead. Now, if I then are super successful, my Hello World at scale, I get VC funding. Turns out that everybody wants some Hello World. That suddenly it looks much more complicated because I have to deal with high availability requirements. So I take my server, and I've got to put one in each geography, which in AWS terms is an AZ, an availability zone. So I've got these servers in each one of these AZs, and now I probably need an image because if it scales up, because Hello World's going to be a huge success, obviously, I need to be able to have my auto-scaling groups load that AMI quickly. Then I'll need security groups for this whole configuration, and it all has to live in a VPC. And basically, that's just to handle this amount of demand I'm thinking about. But what about if Hello World is a huge failure, that actually it turns out it's not that successful as an idea? Well, because of HA, I can never go below 2 servers. So I have these servers literally sitting around doing absolutely nothing. And so you come back to the fact this core logic is just this one line of code. And the serverless approach helps developers focus back on this business logic. So if you think about this as a serverless app, and I built this a few days ago just as an experiment. It took about 5 minutes, actually. What it looks like is this. I've got a Lambda function where it's going to return a bit of JSON, just a status code, my hello world text. Then in front of that Lambda function, I'll put API gateway as an endpoint. And that's it. And I ran artillery on this for 1 million requests over a 24-hour period, and it performs just fine. So what this shows in this very, very simple example is that this is massively scalable out of the box. I didn't do anything special, and it scales up pretty aggressively. It's also highly available out of the box. If the Lambda service has a service disruption in one AZ, it will automatically run the function in another AZ without you needing to do anything. It's also very secure. So if you look at this, I can configure Lambda to only ever be able to run this code and configure API gateway to only ever run this Lambda function. So I've managed to create a fairly solid security posture very easily. Now, before I joined AWS and I had teams of developers, about 20% of their time was spent managing these server infrastructures. And when you're doing it serverlessly, the sorts of things you don't need to manage are things like this. And you think about when you're running EC2 or any virtualized server or on-premise server, you've got hard disks and operating systems and sudo yum updates and all sorts of things you have to do. And I've actually not touched an EC2 instance in so long. When I looked at the list, I was actually surprised that we did a lot of these things. So really, it comes back to the key of why serverless is so different, is it's about you focusing on this business logic and not the machinery that's running underneath it. And this is one of the reasons that Lambda has now got hundreds of thousands of active developers every week. And it's one of the reasons why we run trillions of invocations every month. So today, the list of enterprises that are using serverless first is growing very rapidly. It's a surprisingly large list. Lambda continues to grow in lots of well-established brands. And these companies demand dependable, predictable performance. But it's also growing with individual developers who need a simple-to-start and easy way to operate and innovate. So after seeing all of these enterprises adopt serverless as a primary way of delivering their applications, I had to ask why. What are they seeing? What's the benefit? What makes this so compelling for them to approach application delivery this way? So in talking to enterprise customers, we repeatedly hear that they choose serverless for 5 main reasons. The first one is time to market. We hear this over and over again. And as you see from Edmunds, they said what took just a few days to build with Lambda would have taken 6 months to build from scratch. Again, this is something we hear from people. They're very surprised when they first start using serverless, just how fast it is to get things out there. And many customers now work in environments where delivery cycles are just getting a lot shorter all the time. The days of the 2-year waterfall model are long, long gone in most places. And most developer teams don't have extra resources or headcount, and they're expected to ship more quickly with uncertain requirements and changing requirements throughout the project. So when you look at how serverless meets this need, it's almost purpose-built to help with accelerating application delivery. So the first aspect is there's no infrastructure management. There's no networks, there's no computers, there's no operating systems, and nothing to patch. We saw that in the Hello World example. The second factor that's more surprising is there's a lot less code usually. So many production serverless systems that we see have 50 to 70% less code than their server-based equivalents. Now, part of this is due to the removal of boilerplate code through various parts of the application, and also the fact that you're using a lot of services in places of things where you typically would be writing things. Now, I tend to believe that code is a liability. That's especially my code. Having less code, it's easier to test. It's easier to pivot when you need to change requirements. It just helps throughout the entire development process. And the well-architected serverless app tends to also consist of many functions that then you can lift and shift into other applications, which also helps accelerate. The third aspect, and I'm actually probably the biggest fan of this, is this frees developers to work on the aspects of your application that matter most. It takes us away from the infrastructure and the things that your customers don't see and lets you work directly with your customers to build features and solve problems that they care about. And one of the things I found with this is it means that developers start to work more iteratively with customers. They deliver things, get feedback, tweak things, put another version out. And you start to produce better software that solves your customers' problems more clearly. And then behind all this, you have this full suite of different managed services that's also a major driver to rapid delivery. Serverless is basically about serverless services. So many people who are new to serverless think that it's about Lambda. And Lambda and serverless are synonymous in people's minds. But Lambda is actually just the functions as a service part that's at the heart of the serverless portfolio for AWS. But in your applications is usually just glue between different services. And using these services is really the key to getting the most benefit out of these serverless apps. So we rely upon services like API Gateway. That's the front door of your application. There's DynamoDB. This gives you web scale, very, very low latency, NoSQL storage for your data. There's S3, which gives you very high levels of durability and also virtually limitless storage for your customer data. And then step functions, one of my favorites, that all that spaghetti code you have in business logic and workflows within business applications, you can pick up and move to step functions. And then there are other services, too, that can help you with events and notifications and queues. And then there are specialized services. So there's Kinesis, for example, if you're dealing with real-time data ingestion, or IoT Core, if you want to work with physical products in the real world. IoT is a great use case for serverless. Or even Elastic Transcoder, if you're working with large media files, this can really help you, too. And behind all this, Lambda can basically connect with almost anything within AWS. So you have full range of all these different services that are out there. Now, the ones I'm most excited about are the machine learning ones. Machine learning is hard to do by yourself, and yet it's a great thing for your business in many cases. So in serverless, it's pretty trivial to hook up some of these services and bring in image recognition, or voice translation, or language translation into your app, often with just a few lines of code. But you can also connect with the Internet of Things and provide analytics and media for your apps. And if you're building web or mobile, there's a ton of different services that can help accelerate delivery in that space. These services are all tools in your serverless developer's toolbox. So you want to mix and match these to solve problems. And the key thing to remember here is that these are all pay-as-you-go services. So whether you are using an enterprise-grade database like Aurora Serverless or a petabyte-scale data stream ingestion system like Kinesis, you can choose what to use, and it's cheap and easy to experiment to find out what works for your solution. So when you combine all the services, you get applications that look a lot like this. So this is a simple application I put together that will take images from a customer, and it will use recognition to figure out what they are, put the labels in a database, send emails, create thumbnails, that kind of thing. And what you see here is that when you use these services, you have more Lambda functions, they're more specific, they're shorter lived. These would only live for a couple of hundred milliseconds, most likely. And the benefits of building this way are multiple. The first is parallelization. You can do lots of different things at once, as shown in this example. The second is that it's very easy to add functionality. If I need a fourth requirement here, where I want this particular solution to do something else with an image, I just create a new Lambda function and make a new subscriber to SNS. And I don't need to change any of the code in any of the other functions. That's very powerful. The functions themselves are highly specialized and reusable. This is something I found early on in picking up serverless, was that I could take functions from previous projects. So I could take one of these, like the create thumbnail function, pick it up, throw it into something else, and not change a single line of code. And this design is also very reliant and scalable. So whether you have one image, 10 images, hundreds, thousands, it will continue to work. So the second thing we learn when we talk to customers is availability. So Custom Inc. found that when they switched to serverless, not only did their costs drop dramatically, but they also increased service reliability fairly dramatically too. Now you'll hear people at AWS say that everything fails all the time. And it's a quote we got from our CTO, Werner Vogels. And what it means is that internally at AWS, we're thinking about availability for everything, and everything is designed to anticipate failure, and we design architecture around resiliency from that point of view. So since the start of AWS, availability has been a top priority. Now today, just outside of serverless, AWS has 22 regions and 69 availability zones, and we've announced plans for 16 more AZs and 5 more regions. Within serverless itself, you'll find there are many services that have HA out of the box. So Lambda load balances across AZs for you, so if you have any sort of service disruption, it will find another region, and you don't need to do anything to make that happen. But many other services in the portfolio, like API Gateway or DynamoDB or S3, they also run in multi-AZ configurations. When you pull these into your solutions, you're building all that availability and resiliency into your own application. So Lambda functions themselves have multiple levers and controls for retry logic and for handling. And this helps you embed good practices into the services and the architecture layer and pull it out of your custom code. So you may have seen a new feature launched fairly recently, Lambda event destinations. This is a mechanism where if you have asynchronous functions, you can route on failure or on success to another destination like SNS, Kinesis, or Lambda. And the idea here is part of the same drive to remove code out of your custom functions and make it part of the architecture. Now, many of the design patterns you'll see also emphasize retry logic and queues and asynchronous approaches. And there are other tried and tested patterns in distributed computing that help improve the availability and resilience of your applications. Some of these are very easy to implement, but have a massive impact on availability. One of my favorite examples that people often don't think about is for web apps. So if you have a modern web app that's using a single-page application framework like React or Vue or Angular, those frameworks compile your applications down to HTML, CSS, and JavaScript. So instead, in the server-based world, where if you had a scalable web app, you would have to scale a fleet of servers when you get busy, all you do in the SPA world with single-page applications is take those assets, put them into S3, and then put a CDN like CloudFront in front of them. And what you've done effectively is now created an entirely serverless delivery system. And whether you have one user or millions of users, and whether they're just in the US or they're all around the world, it will deliver them a low latency download experience for your application. Another big consideration is multi-region. This is actually a lot easier with serverless applications. So in serverless, most applications can be fairly highly available just in a single region. But if you want to design for higher and higher levels of availability, you can throw in solutions that combine multiple regions. So at the data level, this is supported by services like S3 bucket replication, which allows automatic asynchronous copying of objects across S3 buckets, or DynamoDB global tables that eliminate the difficult problem of trying to synchronize data and resolving update conflicts in different regions. And at the compute level, you can also deploy Lambda functions in different regions. We have lots of automation tools that can help you do that. API Gateway itself can be deployed in different regions using that sort of logic too. And you can implement Lambda at Edge as well. That can be deployed at any one of our 216 CloudFront points of presence. So there's lots of different architectural choices you have available for designing multi-region. So performance is another benefit that people are finding with serverless. Square Enix said that Lambda had a striking effect for their applications, and image processing that used to take several hours was finished in as little as 10 seconds. And this is a very common sentiment we hear from companies, especially when they're dealing with highly compute-intensive applications. So performance continues to be an important reason why enterprises choose serverless. And one of the reasons why the performance is so good comes down to continuous improvement. So AWS services are built using the same building blocks that our customers use. There's no secret pool of servers or things that we're using internally. We literally use the same things that everybody else uses. And as there are improvements in the speed and reliability and latency reduction in all of those pieces of equipment and networking and underlying services, we all benefit from those changes. There's a considerable constant effort internally to make improvements at every possible level. And at the scale at which we operate, at trillions of functions per month, even having very small improvements on a regular basis can make very significant performance gains. Now, concurrency is another major performance factor. So one of the biggest benefits of using Lambda is it can scale very, very aggressively from a single function to thousands of functions very, very quickly. And all execution models, whether they're synchronous, asynchronous, or polling-based, benefit from this approach. So for apps with heavy traffic, especially ones with spiky workloads, where that's very difficult to predict, this means your apps can keep up with demand. Now for apps with very intensive processing, such as image recognition or data processing, parallelization can also make a huge difference. You can take tasks and break them up into smaller and smaller chunks and have multiple Lambda functions process that to reduce the overall time things take. And then there's a couple of other things we announced fairly recently. We announced changes to VPC plus Lambda and also provision concurrency. And I'll talk about those in a little bit more detail. So it used to be the case that enterprise customers put their Lambda functions inside of VPC because it gives them access to services like RDS and Elasticache and various other things. Also, if they want to use resources on-premise, they can connect using Direct Connect. But a couple of the problems with this before we made all these changes are that this can be very, very resource intensive on the network side. As Lambda scales up, it can use a lot of elastic network interfaces and other IP address drainage problems. And also, you'll find that there's a cold start issue where, as Lambda connects to the VPC, it can take a while to connect and get ready. So we took a major engineering effort last year to solve this problem. And we rolled this out between October and towards the end of the year into all the different regions. And what we found was we could get this cold start down from this about 15-second range to almost nothing. So in this example here, it went from 14.8 seconds down to just under a second for the entire execution of Lambda function. Now, customers don't need to do anything to benefit from this. This is something that we rolled out, and it's invisibly a benefit for everybody who has a Lambda inside of VPC. But it's made an enormous difference to enterprises because they use this combination so frequently. A second feature is provisioned concurrency. So this is an odd name, but actually for a simple problem. So most of us use Lambda on demand. We have the code ready, and we want to use it. We simply fire it up, and it loads the code and runs. And you'll often find there's an experience of a cold start when you haven't used a function in a while. And there's two causes of a cold start. One is the time it takes us to get the execution environment ready for you. Literally, that means preparing space within the Lambda service, downloading your code, and getting it running. The second cause is on your side in terms of static initializers. If you have anything running outside of your function handler that's slower, that can contribute towards a cold start. Now, cold starts in practice only affect under 1% of all production invocations. But there are workloads where even that 1%, it's too many. Customers need to basically have a zero latency environment. And that's why we created provision concurrency. So this is very easy to use. It's essentially an attribute you can access from the console, from your SAM template, or from a CloudFormation template. And you can configure how many execution environments that you want to run. And the service will make sure those are ready for you when you need them. Now, if you don't know how many of those that you're going to need, you can also use auto-scaling. So you can set a minimum and a maximum and a target percentage, and an algorithm will work out the number of containers that you need available. So this is a great solution if you need a zero latency approach to your Lambda functions. So a fourth factor for enterprises is cost. So Financial Engines said that they saw a 94% saving in costs when they switched over to Lambda, not including operational maintenance. So cost is a huge driver now in IT for companies of all sizes, but especially in enterprise IT. Many enterprises have investments of millions or even hundreds of millions of dollars inside their IT infrastructure, and they're looking for ways to lower those costs and to improve the ROI. Now, you might have heard of the Amazon leadership principles, and one of our principles is frugality, and it's a real thing. So we actually connect with this cost need very, very well. We're all about driving down cost. So there's some things to think about when you look at cost. One is total cost of ownership. So when you run applications on-premise or inside your own cloud environments, you have teams of people in your company, security, networking, operations, and the cost of those teams is amortized against the number of applications that you have running within your business. When you look at AWS, we have thousands of those engineers doing those jobs, but the cost is amortized against hundreds of thousands of customers and the amount of Lambda invocations that you make. So that amortization makes a big difference. And there's significant value in having your infrastructure managed by AWS instead of doing it yourself because of this reason. The second is scale. So it's really surprising when you look at enterprise apps running inside EC2 that generally they don't make great utilization of their resources. So in all of the studies we've done, we tend to see that companies use between 10 and the low 20s in terms of percent of the CPU available of those boxes. Why is that? Well, partly it's the HA requirement we saw with Hello World, that you have to have extra servers in place. And partly it's because of disaster recovery. You have machines just sitting around that literally are doing nothing until they're needed. But within AWS and the Lambda service, because we're working with workloads across thousands of customers, we can pack those workloads within our execution environments with amazing efficiency. So we get much, much higher levels of utilization. And that's another reason we can drive down cost. Now, also, we announced savings plans for Lambda. And this is a huge benefit to companies that may have taken on savings plans in November. So last November, we said that we were rolling this out for various compute services. And then last week, we made it so these same savings plans are available for Lambda and Fargate. Now, what this means is that you can take up to a 17% price cut, effectively, on Lambda if you migrate your savings plan. But probably the bigger benefit is if you're looking to move from EC2 to Lambda and you have a savings plan, you can effectively use the same savings plan to do the migration. Now, we have periodic price reductions at AWS. Since the service started, we've had 80 different price reductions over time. And it's a normal part of business for us. So we continue to expect to lower prices this year and for many years to come. And our pricing philosophy is to work relentlessly to take the cost out of our own cost structure and pass that on to our customers in the form of lower prices. But there are cases where we see good opportunities to take a service-level approach to this and make changes to services to pass along even bigger price savings. So one is HTTP APIs. This was announced fairly recently. And basically, customers were telling us that for API Gateway, which is a tool with a lot of different features, many customers were not using all of those different features. And they wanted to have a more slimmed-down service that had a more cost-effective approach to their applications. So HTTP APIs is what we built to answer that. It gives you a new console experience. It's a streamlined offering that gives you JWT authorization, default stages and routes, and CORS integration. But whereas API Gateway is $3.50 per million requests, HTTP APIs is only $1 per million, dropping to 90 cents at a certain price volume. And also because the application is a smaller footprint on our side, often you can achieve a much better latency as well, up to 50% in many cases. So we expect that many API Gateway customers could move from their existing usage of API Gateway to HTTP APIs, because we've looked at the subset of usage people use and produced a service that offers those features. So many customers could switch across to this and make a big saving on their AWS bill. Now, we also have Step Functions Express workflows too. So if you're a Step Functions customer, you'll know that Step Functions cost 2.5 cents per 1,000 transitions. Many customers have workflows that are very fast, and this is our reaction to this. So basically, this lets you cost-effectively orchestrate across compute, database, and messaging for event rates greater than 100,000 events per second. And this is really built for people doing IoT data ingestion, streaming data processing, and high-volume microservices. So for many workloads, this can actually be a better approach and a cheaper approach than using standard step functions. So I don't need to tell anybody in the room about how important security is becoming in our industry. And last week, you may have seen a couple of headlines. So one saying security concerns hampering adoption of containers and Kubernetes, with 90% of customers saying they saw security incidents and deployments in the last year. So this is not a ding on containers or Kubernetes. So AWS Fargate runs tens of millions of containers for customers every single week. And across the cloud, 81% of all containers in any cloud run on AWS. So we understand containers and Kubernetes extremely well. But what it highlights is the difficulty of you running and configuring this infrastructure yourself. And when a lot of enterprises are choosing serverless, a big driver is deciding that they don't want to basically have that security posture. They want to have an easier approach to security. Now, security is job number one at AWS. You'll hear this from AWS people all the time. But all of us have a role to play in this room in security in our workloads and applications. This is no longer a thing where we can say, oh, it's just the security team's problem. It's something we all have to think about. So serverless has a number of mechanisms available that help with security. One is the shared responsibility model at AWS. So if you've heard of this, this means that AWS is responsible for the security of the cloud. This is the data centers, the machines, the cables, the hard disks, the physical environments, the operating systems on those actual machines, the hypervisors. All that stuff is our responsibility. Customers are responsible for security in the cloud. This means basically using best practices to secure your data and your applications. Now, there are some benefits in having AWS manage slightly further up the stack in the case of serverless, where we manage the underlying EC2 resources that power this service. When the Spectre and Meltdown incidents happened, we were able to patch all of those EC2 instances under Lambda before the incidents were even announced. You also have to consider minimizing your blast radius, which is something you can do fairly easily with the granular permissions that are allowed with Identity and Access Management, IAM. So for every resource, every function, and every service in your app, you can consider its security posture. We also have deep integration with Cognito throughout AWS services, so that can help form the bedrock of your serverless security. And you can easily wrap up your Lambda functions with a strong security posture using IAM to maintain a high level of security and also help meet your compliance requirements. So it's important to think about minimizing the blast radius at each and every step of your application, because serverless doesn't have the perimeter level security that we're so used to in the server-based world. This is much richer. Now, a critical part of making developers part of the security process is making it easier for developers to be part of that security process. So frameworks such as SAM, the Serverless Application Model, make it easy for developers to specify access policies on their functions using YAML. And also we provide managed policies in SAM as well. So we've got 40 or so different common policies that you can easily implement in your functions. Recently, in December, we announced that Amazon S3 access points is a way of helping developers, making it easy to manage access at scale for shared data in S3. And we also, last week, announced CloudFormation stack sets for multiple accounts, which also helps you roll out security policies to multiple accounts within organizations. So one of my favorite documents is the well-architected tool. And this is a fairly beefy document that's worth reading about developing architecture in the cloud generally. Fairly recently, we introduced the serverless lens, and that tells you how to architect things using best practices for serverless applications. We announced that this is now a tool within the console. So if you pull in your workload into the AWS console, you can run that against this tool, and it will analyze it for any security problems it sees, and also apply best practices and operational recommendations. It's free to use, it doesn't cost you anything, so I highly recommend checking this out in your console. So those are the 5 reasons why, but it doesn't end there. We've worked to produce a suite of features and tools designed specifically for enterprise developers in mind. First, we're making it easier to integrate with other systems and their data. And second, we've created a complete suite of enterprise tools for developers. So developers need to be able to integrate with existing systems. And one of the services I'm most excited about was announced last year is EventBridge. So EventBridge can really help accelerate development by turning data into events within your applications. Now, for enterprises, I think this goes a long way to solving 3 very common problems. If you're used to developing applications with APIs that integrate with upstream services, you know those integrations often get very, very brittle, and it can feel like you're just working within one giant monolith. By decoupling the producers of data and the consumers of data, by putting an EventBridge, event bus in the middle, you can actually start to pull these 2 things apart, and that can make a huge difference to your speed of development. It can also help standardize data, because if in an organization you have data coming in from all sorts of different data sources and webhooks and various databases and so forth, you can turn those into events and create a common way to ingest and understand those events. And it also simplifies processing. So it's easier for developers to think about dealing with a batch of one, working on a single event. And then if that works, and you've got your logic down, it then scales up to thousands or tens of thousands of events. One of the famous Lambda use cases, the image resizer example from years ago, is exactly that. It takes an event from S3, processes it with Lambda to do the work on the images. So I think this sort of event-based approach will go a long way to making life easier for enterprise developers. SaaS is also becoming a big issue for enterprises. More and more companies are putting critical data on SaaS platforms. So EventBridge now integrates with 21 different providers, with a growing list of providers coming on board. And that makes it much easier to put data in and pull data out of those systems. To dive a little deeper on this, I put this slide together. I'm very excited about EventBridge. EventBridge truly has the capability of making events universal. So if you imagine having a Stripe integration with a webhook, you could put an event bus behind that pretty easily. If you've got custom apps, you can have those published into an event bus too. If you have third-party services like Auth0, Datadog, PagerDuty, and Zendesk, they can put events into the event bus within their own AWS account, and those will appear within your partner event bus in your account. And that's a particularly neat solution because those events don't travel over the internet at all. They go through the AWS backbone. So it's inherently more secure than trying to fetch them using APIs with static secrets and that sort of approach. If you have multiple AWS accounts, you can publish those events to event buses across those accounts. So as a developer, you create this environment where you've got events all over the place inside your AWS ecosystem. And all you have to do then is to write rules. You write rules to consume the events you care about, and then you can select targets for those rules, which could be Lambda functions, Kinesis streams, SNS, and other destinations. And fundamentally, you've decoupled yourself from your corporate infrastructure. So I think there's a lot more to come with EventBridge, but I'm really excited about this as being a fundamental change to the way that we make serverless work in organizations. Now, data is also a hugely important part for enterprises too. So building data lakes used to be fairly hard, and frankly, with serverless, it's a lot easier for both the ingestion of data real-time or through batching, or for processing and making sense and using ETL on data coming through your ecosystem, or for analytics and business intelligence to take all that data and apply insights into what you're seeing. So our tools are making it easier to perform complex queries and analytics. So developers today build highly distributed applications using a multitude of different purpose-built databases. And as the number of data stores and applications increases, running analytics across those data sources can become very challenging. So federated query is a new Amazon Athena feature that enables engineers and data scientists to execute SQL queries across data stored in relational databases, NoSQL databases, or object stores, or custom data sources. And since all those connectors run on Lambda, they continue to benefit from Athena's serverless architecture, even as they face peak demand. And then we've also recently announced Rds Proxy, and customers needing the benefits of scalable compute when working with relational databases and ADS. So you've got this issue where with DynamoDB, we often say to people this is a great choice for serverless applications because it scales so well with Lambda. But the reality is for enterprises, they often have petabytes of data that's tied up already in RDS, and it's become critical for them to ingest data from those systems. So the problem you have is that relational databases work on long-lived connections with servers. So they're expecting to have a pool of servers available that will be there persisted for a long period of time. When you have a Lambda function that may scale up to hundreds or thousands of different concurrent instances, and they're all getting connections from the RDS data instance, it can cause problems for the database simply because those connections are a memory resource. So how can you solve this problem? Well, Rds Proxy was built to solve exactly that, and it stands between your Lambda functions and your RDS instances. And all you have to do to use this is to point to Rds Proxy instead of RDS, and you can then consume that resource. It also can make apps more resilient due to database failures, and it can also help in security as well because of other bells and whistles that are built into the service. So this is currently in preview, but we're seeing a lot of pickup from companies who want to be able to connect with their RDS resources. So we have this other complete set of tools at the enterprise level that often people are not aware of, and I just wanted to highlight a few of the ones that are my favorite. One is X-Ray. This is a great tool. It's a distributed tracing technology that lets you follow a request path through all the different layers of your app to identify issues. It lets you analyze and debug throughout your distributed architecture, and whether you have a single API call or an N-tier web app or an application consisting of thousands of different services, it makes it much easier to track those calls. Within IDEs, we know developers like to use their IDEs, and so we're building more and more integration with those. There's Cloud9, which is our cloud-based IDE that runs in a browser. This is fantastic for development on a plane, by the way. I spend a lot of time on planes. Cloud9 is a great way to do development. But there's toolkits for PyCharm and IntelliJ. And if you're a VS Code person like I am, we have a growing number of extensions that can help pull the serverless environment directly into the IDE, so you never need to leave the console. And then there's step functions, which is, again, one of my tools that I use very frequently, because in business applications, you have this spaghetti of workflows that exists in distributed computing. And often when those workflows change in your organizations, it's really, really hard to make sense of what changes where. It becomes extremely difficult. With step functions, you can extract all of that logic out of your code and turn it into JSON or YAML and visualize it inside step functions. And you can very easily create scalable workflows that solve a lot of your coding problems. And then there's Event-Bridge Schema Registry. So I talked about this a little bit earlier, about Event-Bridge. But events are nothing new, but they do come with a problem. And that is when everybody's producing events, it's very hard to make sense of what all the different formats or schemas of events look like. So Schema Registry was designed to solve this problem. It can ingest all of the events coming into your environment from AWS or your custom apps or your SaaS providers, and it will understand the schemas and put them into a registry for you. One of the really great features is it can generate code bindings. So if you're using a type-safe language like Python or TypeScript, you can download those code bindings directly into IDE and build applications directly from an event. So again, there's more to come on this because it's a very new feature, but it really helps accelerate development. So since its creation 5 years ago, Lambda has become one of the fastest growing services within the AWS portfolio. And this is largely due to the thanks that enterprises see what it can do for them. And they've adopted this approach for some of the most difficult workloads that they have. So whether it's Airbnb or National Geographic or Dunelm or Expedia, these enterprises are looking for the best tools and the services best suited for their workloads and for their developer teams. And in the 5 reasons why, time to market is cited again and again and again as the most critical benefit that our enterprise customers are seeing. Enterprises have found that they're better off freeing their developers to focus and work on the features that help drive the disruptive agility of modern applications. They've also found that for many of their applications, that serverless is the best choice for achieving availability and performance, and also controlling cost, and implementing a strong security posture. And when you add these together with the rich set of tools and capabilities available today, this is why so many enterprises are choosing to develop with a serverless-first approach. And it's quickly becoming the case that serverless is not just where you build, but serverless is how you build. So thank you very much. My name's James Beswick. I'm at the conference all day if anyone has any questions. I hope to see you all a bit later, and I hope you enjoy the rest of your day here at ServerlessDays Nashville. Thank you once again.